Good morning, students. Today we are going to discuss an important long answer question in the final examination. The question is, what are the graphs and explain types of graphs? Once again repeating you. The question is, what are the graphs? Explain types of graphs. So actually, what is the definition of a graph? Graph is nothing but a collection of vertices or nodes. Okay. Graph is nothing but a collection of vertices or nodes is called as a graphs, which are joined as a pairs by lines or edges. So generally diagrammatical representations of graph are like this one. So these are the different types of graphs representation through graphically. Okay. So here, as per graph definition, collection of vertices or nodes. So what is the vertices? This is the vertices. What are the data that should be contains? That is a vertices, or alternative name that is called as a node. Okay. The next one, which is called as a arcs. Okay, which is called as a arcs or lines. Okay, or edges. Okay, whatever should be calling. So as per graph definition, collection of nodes and okay, collection of nodes and edges or collection of vertices or edges is called as a graph. Okay. So generally graphs are used for to represent the directions of a movement or one way. Okay. So for example, in the real life, we wanted to went to somewhere locations. Okay. So for that, in which locations that should be better to reach our destination in the shortest time. Okay. So actually in the shortest path need to represent to reach the destination in the short period. Okay. For example, we want to reach us a certain location. Okay. So in which way we went to go, in which way we went to go in shortest path that can be choosing the particular graph. Okay, actually graphs are represented for, so and the directions for reaching the destination in the shortest period. So for that we are going to use the graphs. So graph is nothing but a collection of vertices and edges. So actually formally a graph that can be represent like this one. G is equal to combination of vertices comma edges. This is the graph representation. G is equal to V comma E. G is equal to V comma E. V comma E. This is the graph representation. And which is an ordered pair of finite sets of vertices and edges, actually, which can be pairs finite sets of vertices and edges. Vertices are also called as nodes. Okay, here vertices are also called as nodes or points. Okay, very important Viva question, that is vertices are also called as a nodes. Node is nothing but this is called as a node. Okay. And alternative name which is called as a points. And edges are called as a lines or arcs. Edges means what? This is edge, this is edge, this is edge, this is edge. Okay, which is called as a edges or lines or arcs. Arcs nothing but ARCS. Arcs. Okay, or lines. Arcs or lines or edges. We need to calling in the alternative names. Okay, combinations of vertices and edges is called as a graph, right? Here vertices are displayed as circles. Vertices that can be displayed as a circle. Okay, vertices displayed with circles. Vertices displayed with circles. Okay, and edges are displayed as lines. Okay, here edges are displayed with lines. Edges are displayed with lines. Okay, vertices are displayed with circles and edges are displayed with lines as per graphical representation of a graph. Okay. Next, an edge with orientation is called as a direct edge. Okay, an edge with orientation, with orientation. What is the orientation? Is nothing but the direction. Orientation is nothing but the direction, specifically direction representation of a graph. This is okay. This is orientation. This is called as a direct edge. This is called as a direct edge. This is called as a direct edge. Just understand? Next, while an edge with no orientation, okay, no orientation, representation like this one. What is that? This is no orientation. This is no orientation, not like this one. Simply, this is a no orientation. Okay, this is no orientation. This is a no orientation. Okay. This is called as a undirected. Okay, undirected edge. Okay, so this is called as a directed edge and this is called as a undirected edge. Okay, so based on this graphical representation, how can it will be performed by the graphs? Okay, so here these are the graphical representation. Here already discussed what is that? Circles is called as a either nodes or vertices. Okay, so which is called as a either edges or lines or arcs. Okay, we need to combine, we need to connect it to one node to another node. We need to connect it to creating a connections between one node to another node. Okay, this is called as a what is that? Combinations of vertices and edges. Okay, so this node connected to this node, this node connected to this node, this node connected to this node. Overall, this graph is called as what is that? Undirected graph, because of in this graph cannot represent the specific direction to creating a connection. Okay, in this connections cannot be created specifically the direction, so that is a undirected graph. Just understand? Without what is that? Without orientation, without orientation means what? No orientation. Now we need to creating a graph is called as a undirected graph. Okay, with orientation here discussed, this is orientation means what? So specifically that can be represent the direction. Okay, source to destination address. For example, this node to this node, so this path is going to this way. Okay, so here clearly represent the direction. Such type of graph is called as a directed graph. These are the difference between undirected and directed graph. Here understand? The undirected graph, we need not to creating a specific direction, cannot be representations of a specific direction, that is a undirected graph. A specifically represent the direction, that is a directed graph. Okay, so in this graph, so number of nodes connected to one node connected to another node, but here an important point observe here, each and every node must and should be connected here in this graph. But coming to here undirected graph, so one node not connected here, this node not connected to this node. Okay, so such type of undirected graph. But coming to here, each and every node connected to another node, that is called as a complete graph. So in this graph, each and every node connected to another node, at least one node. Okay, that such type of graph is called as a complete graph. Okay, right. Next, what is a complete digraph means what? So each and every node connected to one node connected to another node with the orientation means what? Specifically to represent the direction. Okay, specifically represent the direction, and each and every node connected to another node. Okay, such type of graph is called as a what is that? complete digraph. Okay, this is a generally complete graph. This is a complete digraph. What are the difference between them? In this way, each and every node connected to another node, but cannot represent orientation, means cannot represent the specific direction. But here, each and every node connected to another node, but specifically represent the direction. That is a complete diagram. Okay, is it understand? So in the real life, so with using graphs representations, so that is very usable in the real life. So what are the applications of graph? Actually, the graphs are used in the electrical networks. Actually, graphs are used in electrical networks. Electrical networks. Electrical networks. In the electrical networks, they have using the graphs representation. Okay, wire routing in the electrical networks. So wire routing we have to creating in which location to another location, means source to destination address, where we need to creating the electrical connections. So that is the electrical networks can be using the graphs. And one more, what is that? Study of molecular structure. Okay, study of molecular study of molecular study of molecular structure in the science. Okay, the study of molecular structures of chemical compounds requires graphs representation. In the chemical compounds representations going to use the graphs. Okay, and one more application, what is the representations of airlines? Representations of airlines. In the airlines also that can be using the graphs. So in which source to destination address that can be represent flight movement, that can be depends on graphs representation. Okay, with the graphs helping, so flight that can be moving the directions. Okay, that is source to destination address. So on that also using the graphs representation. And one more, that is in the application networks. The networks also, the networks also that can be using the graphs. Okay, how to creating the local area networks and wild area networks to creating a connections. Okay, how can it will be performed to networking applications. Okay, all those things that can be supported by using graphs representation. So in this way, specifically to creating a networking connections in between the client to server systems, and local area networking, wild area networking. So in this situations, also graphs are using. That is one of the application. And topological sorting techniques is also that can be using topological sortings, also using the graphs. And finding shortest path. Okay, in the shortest path representations also with the help of graphs. Okay, so these are the some applications of graphs representation. Okay, so this is an important long answer question. Maybe it will come in the final examination. Maybe it will come in the final examination as a long answer question. Okay, thank you.